Hi everyone, this is Xiangyu Lyu. Today I want to share a project I did during my study, the Ebola virus spread model project. I will introduce it by four parts: background, two models we simulated, and the conclusion. So for this project, I will talk about the 2014 epidemics of the Ebola virus disease that was widespread in West Africa. This disease had an incredible high fertility rate and was transmitted mainly through human-to-human contact of bodily fluids and the contaminated clothing. It resulted in the deaths of thousands and greatly impacted the socio-economic status of many countries. In some West Africa countries, traditional funeral and burial of the deceased involved physical contact with the bodies, such as washing, kissing, and touching the corpse. This motivated us to study the impact of funerals during the epidemics and discover some intervention methods so that we can get a better understanding of the spread of the viruses. Our group built two models by using Python. To get started with the SIR model, which represents susceptible infections and removed respectively. Ideally, we assume that the total population is a constant n in this case. From the graph, we can see that as the susceptible people get infected by a certain rate, the purple line falls sharply and the red line increases to a certain point where people generally get recovered or dead. Based on that, the green line, which means people removed from the infectious process, increase exponentially to the population n. In order to indicate the effect of the funeral, we add parameter f to estimate the SIFR model with a few assumptions. There are amount interactions that causes the susceptible decrease repeatedly to infected classes. The infected people increase constantly to a peak and moves to the funeral compartment caused by the contact occurring at the funerals. Lastly, those who died from Ebola goes to the removed class. After adding the funeral compartment, it is obvious that the green line becomes flatter since there are lots of people get infected during the funerals. So to discover the influence factors of the epidemics, we mainly focus on the effect of two intervention strategies. The first one is controlling the funeral spread rate since the traditional funeral and burial is one of the main contributors to the virus. By setting the beta F parameter from a rate of 1 to a lower rate 0.1, we can see that there is a slight change in the infected population. So some prevention methods can be applied, such as avoiding funeral or burial practice that involve touching the bodies of who died from Ebola, and limiting the number of people present at the funerals. The second one is developing the vaccine by implementing an additional parameter of vaccination weight. As we can see, as the vaccination rate improves from 0.5 to 0.8, the infected population at the beginning will rise to a lower peaks. And the funeral spread will also decrease as there is a less infected population influence to F compartment. As a result, the growth of the susceptible population will slow down at the beginning. Therefore, the application of vaccination in this case is effective. We can see a decrease in the mortality of the Ebola. According to the data we gathered and the experiments that scientists carried out, the fertility rates of Ebola can reach to 90%. At least 20% of new Ebola infections occur during burials of the disease Ebola patients. Therefore, controlling funeral spread will save at least 20% lives in Africa. And with vaccination, 80% of people being vaccinated will have at least 50% chance getting recovered. So Ebola can be controlled effectively by controlling funeral spread and vaccination. Thank you.